My Smart Streetlight app uses two databases. Firstly, a Streetlight database. Transport for NSW does have a database of streetlights, however it's incomplete and shows a limited amount of data. Therefore, we're using raw data, which is scraped from Oswood server. Currently, we have gathered 9,238 unique streetlights around the Sydney CBD. This raw data is then passed through a Python script to collect the latitude and longitude. The next database is the pedestrian counts. Luckily, the city of CBD does have a database which shows the walking count around the Sydney CBD. This data shows the location of the counts and the specific time periods. For example, at 6 p.m. on a weekend in spring 2015. There are two issues in datasets. Firstly, there's no data or limited data in 2018/2019 due to COVID-19. This is not capable of being fixed, however, the rest of the data is sufficient enough to be implemented into our app. The next issue is that we don't have the latitude or longitude of the pedestrian count locations. It only tells us the name and place, for example, King Street or Broadway. This can be fixed through geocoding, which is a process that converts the name and place to get the latitude and longitude. However, some names of places are identical throughout the world. For example, there's a King Street in Sydney, a King Street in Melbourne, and a King Street in Cambridge, United Kingdom, and so on. This is solved through using geocoding from the Mapbox API. By using a script, we tell it to only collect the locations which are closest to the Sydney CBD. The latitude and longitude is then added onto the pedestrian count database. This makes it more efficient compared to calling the Mapbox API every time we need the location. The two datasets mentioned after being parsed are then converted into REST API using Flask. This allows us to retrieve the data in a JSON dictionary, which can be fetched through our app. The Smart Streetlight app uses a React frontend, which is built on top of a map using the Mapbox API, which uses Leaflet, a JavaScript library. The app has three main components: a pedestrian count, the Smart Streetlight brightness change, and an analysis showing the total pedestrian count, streetlight wattage, and total cost. The pedestrian count is pretty simple. It gathers the data from the API, spits out the specific time frame based on user input, creates a marker based on latitude and longitude, and creates a circle whose size is based on the pedestrian count at that location. The streetlights are a bit more complicated. Using the data fetched from the Streetlight API, it places marker on the latitude and longitude. The brightness is then determined by the pedestrian counts. There's influence distance on the streetlights, which means that any pedestrian counts falling into that range gets added onto the streetlight's total brightness count. The brightness count is linear. For example, if the pedestrian count is right on top of the streetlight, it takes 100% of the count. If it is 10% of the influence distance, it takes 90% of the count. If it is 50% of the influence distance, it takes 50% of the count, and so on. Currently at max brightness, it will need a count of 50,000. This is proportional, so if the streetlight had a count of 25,000, it would have a brightness of 50%. For the analysis, the pedestrian count is simple and just gathers the total sum of pedestrians at the time inputted by the user. The total wattage is a bit more trickier and requires gathering the data for the brightness count and summing the total. The max wattage is set currently at 100 watts. The price is then calculated from this amount at 30 cents per kilowatt hour. The app, as shown, allows you to turn on and off the pedestrian counts and the streetlights changing between different time states, such as year, season, weekend, weekday, and time. You're also able to see the pedestrian count at each location when hovered. As mentioned before, there's limited data in some years due to COVID-19. We're also able to tell trends. For example, in 2020, there are far less pedestrians compared to other years due to the global pandemic. The pedestrian count is quick, however the streetlights have a couple second delay due to the vast amount of markers being placed and the brightness levels being calculated. As you can see, obviously it's brighter near the center of CBD and dimmer the farther out. One major point is that of course there should be no streetlights being turned on during the daytime. However, it is implemented to show the functionality of the app. Therefore, this app should be used for analysis when the streetlights turn on at and after 6 p.m. The analysis also comes in handy. For example, at 6 p.m. on a weekend at 2021 spring, the total smart streetlight wattage is around 203 kilowatts, which costs $61 for the hour. In comparison, currently if all 9,238 streetlights were at 100% brightness, it would be 924 kilowatts, which costs $277 for an hour, a 78% reduction.